Hello guys, good evening. This is Bharat and welcome to the video session on Mission Gate 2022 Electrical Engineering. In the previous videos, we have seen about covering the syllabus through questions for every topic in the GATE syllabus. We've seen how to approach power systems and how to approach analog electronics and power electronics and digital electronics. And in this video, we'll see how to cover the topics through questions. That is, what we'll do is we'll pick every topic that is given in the GATE syllabus, and then we'll go to what are some possible questions that can appear in the GATE examination, and through this we'll complete the whole syllabus. At the end of this lecture, you will be able to know what types of questions you can expect and what are the topics that you have missed while preparing, either by mistake or purposefully you have missed out, but that is important for the GATE examination. So a bit about myself. I am Bharatchandra and I have graduated from IIT Bhubaneswar in 2015 in Electrical Engineering Department. I have secured a rank of 46 all India wide in GATE 2021 and a rank of 39 in Engineering Services Examination 2020. And in GATE examination 2016, I have secured a rank of 337, through which I have gotten into Indian Oil Corporation. So, along with IOCL, I have gotten into Power Grid Corporation and IISc for MTech as well. And in 2019, I took AP Transco examination where I have secured a rank of 39 statewide. So, I have worked in Indian Oil Corporation for 3.5 years. This is about myself. This is our Telegram channel. So where if you have any doubts regarding any topics that you have in your mind, that is if you have any doubts in your mind regarding upcoming GATE examination, so you can join this channel and you can get your doubts solved by your friends or educators here. The link is given, that is https://t.me/creatrix-gate-ee. The link will be given in the description and you can click on the link to join the channel. So this is our Telegram channel. And then Unacademy is conducting All India mock tests for GATE 2022 for every branch, say electrical engineering, mechanical engineering, civil engineering, and every branch. So these tests are conducted on every Sunday, which has commenced from Jan 2nd. And the second test was conducted on Jan 9th. So the upcoming tests will be conducted on Jan 16th, 23rd and 30th. So you can scan the QR code given here to enroll in the All India mock test series of Unacademy. So the benefit of these test series are this test series is absolutely free. So the number of students appearing for these mock tests will be more the participation accurate will be the analysis of your ranks and all. So whatever ranks that you are seeing in these test series, that will almost appear in the final examination, because whoever are serious aspirants of the GATE examination will take this mock test, this test series for sure. And also this test series will help you in the way that you will know what topics you have covered and what topics you might have missed, and also to have a proper analysis of any subjects where you are lacking and where you are your concepts are lacking and where you are good at your concepts. That also you can know by attending these tests. So scan the QR code given here to enroll for the test series. So Unacademy Plus, you will have live access to the live classes for the stream and for the examination that you have subscribed to. And here you will be having weekly tests, and the courses are structured. These courses are curated by topmost educators of Unacademy, and you will be having unlimited access to the videos for the stream that you have enrolled in. And you are having rank improvement batches. These rank improvement batches are for those who are almost at the verge of converting the examination into any MTech course or in IITs and NITs, or conversion of PSUs, but could not crack the exam and just fell short before converting the exam. That is, those who have scored 1000 to 2000 ranks in GATE examination. And you have crash courses. These crash courses are for those who are good at basics and have less time for exam preparation. So coming to Unacademy Iconic, along with whatever you are getting on Unacademy Plus, you will be getting several features such as personal coach. That is, you'll be getting one-on-one guidance for preparation, and you will have dedicated doubt clearing educators. And the preparatory study material is specialized. You will be having customized study plans, and your it will be tracked by the personal coach who is assigned to you, and you will be having study booster sessions. So this is about Unacademy Iconic. Now coming to the subscriptions, for Unacademy Plus subscription, you need to pay 1967 per month for 24 month subscription, and you need to pay 4917 per month for 3 month subscription. And at the time of checkout, don't forget to use my code kb11 for extra 10% discount. Coming to Unacademy Iconic, you need to pay 3467 per month for 24 month one, and 7082 per month for 6 months course. At the time of checkout, use my code KBC10 for extra 10% discount. So this is again the feature of Unacademy Iconic. That is, you'll be getting live mentoring product. A mentor will be assigned to you who will be tracking your performance, and who will be discussing with whom you will be discussing your doubts, and also you'll be clarifying your concepts and everything. So it's one-on-one live mentoring. So he'll be available on that all the time for clarifying your doubts. So now coming to special class features. Since this is a YouTube class, in the special class, you will be getting the class will be more interactive, and the class is free. You can attend the class at free of cost. You just need to have Unacademy application. So the classes will be more interactive than YouTube classes, because all the students who are participating, they'll get into live chat. They will post their queries whatever they have, and you can get your doubts cleared during the class itself. And the polls will be created by the tutors, and they are available for all the learners, so that you can respond to all those polls, and you can also know your understanding, what your understanding of some topic is. If your answer is wrong or right, based on that you can analyze if you are good at the topic or not. You can use raise a hand option. If you have any doubt, you can click on raise a hand button to raise your voice and get your doubts resolved. So you'll be getting notifications, customized notifications as well. And lecture notes you will be getting at the end of the lecture. That is, whenever the lecture gets finished, you will be getting a PDF version of the class notes. So this is about Unacademy special class. Now coming to Unacademy Ask a Doubt. So this is a new initiative taken by Unacademy. If you have any doubts regarding whatever topic that you are preparing, so you can take a picture of the doubt you have, and you can crop the picture, and you can upload it in the portal, and you can get your doubts solved in your preferred language. So this is just this is very simple to get your doubts clarified. So now coming to our main topic, that is our topic, that is covering the syllabus through questions. Now we are looking at electrical machines topic. So we'll first look at the syllabus. So first we'll cover transformers. In transformers, we have things that are given in the syllabus are single phase transformers, where the syllabus mentions equivalent circuit of single phase transformers, open circuit tests, short circuit tests, efficiency and regulation. And then we have auto transformers, and then three-phase connections. That is, we have many different three-phase connections: open delta, Scott connection, Y delta, delta Y, and delta delta connection. And then we have parallel operation of transformers. So we'll first see what are important topics with respect to single phase transformers. So these single phase transformers, before going into single phase transformers, one important thing that you should be good at, or you should get your doubts clarified in, is magnetic circuit. So sometimes questions are asked from these magnetic circuits. Although it is covered in electric circuits topic, it has more relevance or practical approach in electrical machines topic. So you should know some definitions, that is, what is MMF and what is reluctance, and how to calculate ampere turns, and how to solve the problems for relative permeability if some iron ring or some magnetic core is given, and its mean lengths and cross sectional areas are given, and number of turns are given, then sometimes you are required to find relative permeability. So it's just nothing but core and magnetic core and air core are in series. So it's just like electric circuit, but only difference is, instead of resistance we'll be having reluctances here. So reluctances are sometimes given directly, and sometimes they are not given directly. So what we need is, we need to find out these reluctances using some formulae. Reluctance you can get from L, that is length of path by mu times A. Mu is product of absolute permeability and relative permeability, and relative permeability of air is taken as 1, unless it is specifically mentioned in the problem, we will take it equal to 1. So basic thing in magnetic circuits is, we will convert whatever circuit that is given to you, whatever magnetic circuit that is given to you, we will convert that into electric circuit, and instead of resistance you will be having a reluctance. Instead of voltage we'll be having ampere turns. So instead of so the equation will be similar to that of KVL. So from there you can play with the problem, that is finding relative permeability of iron, or finding relative permeability of air, or finding the number of turns that should be there on iron core, such that this amount of flux is achieved, and flux density is achieved, and all. So basic thing is, basic things are using KVL here, and making ampere turns equal to flux density times reluctance. So from there you can get everything. So it can be either circular core, or square core, or anything, but your approach should be the same. So these magnetic circuits, it will mostly, if it is given, it will come for 2-mark question. I think in 2020 there was one question from this topic. So as I have told you, the series in the series magnetic circuits we'll use this KVL type of approach. In the parallel thing, what we do is we make reluctance time flux equal, in which is equivalent to voltage here. Since in the parallel path, in the circuits, what we do is voltage across parallel paths, n number of parallel paths is same. Here in the same way, here in the same way, the flux times reluctance will be same here. So that is one thing. So another thing is the formula for induced EMF, that is based on Lenz's law. So you should be you should be good at applying this Lenz law, because it involves sign convention. So you should follow some rules for getting, in order to get proper sign convention. So this is about magnetic circuits. So now coming to transformers. So transformers will have so many approximations and all. So you should know what approximation you are using to arrive at no particular circuit, because each approximation will lead to different transformer equivalent circuits, single phase equivalent circuits. So you should know which approximation lead to what type of equivalent circuit. And also coming to equivalent circuit, from that you should know Phasor relationship between induced EMF and exciting current and everything. And also what is magnetizing current and what is core loss current, that you should know. These everything that is mentioned now, that I have mentioned, you can get from vectorial representation. That is what is magnetizing current and what is core loss current. Magnetizing current is no load current times sin theta naught, and core loss current will be I naught times cos theta naught. So this cos theta or this power factor at no load will not be given to you. Instead of giving this power directly, what they will do is they will be giving you a core loss and induced EMF, and current will be given. And one more thing is, if it is mentioned in the problem that the transformer is a three phase, then it is fine. Otherwise, unless it is mentioned, you take it to be single phase transformer only. If the induced EMF is given to you, say 210 volts or 230 volts is given to you, you need not multiply it by root 3 times. So this is one type of mistake that students can commit, or committing frequently. Since the transformer is single phase transformer, you need not multiply it by root 3 times to get line voltage. Here line voltage, phase voltage, everything is same in single phase transformer. So this power factor you can get by division of this core loss with induced EMF times RMS current. So RMS value of voltage into RMS value of current into cos theta naught is equal to no load power loss, no load core loss. So RMS, whatever that is given to you in the examination, that will be RMS only. So you need not bother much about it. So from this you can find out this theta naught. From this theta naught you can find out magnetizing current. From that you can find out core loss current and everything. From this no load circuit parameters of transformer can be found, that is G and B. So this is one thing. And other important thing is, sometimes you will be given it is exceptional case, but what can happen is sometimes you might be given a BH curve of a transformer, and BH transformer will be given to you, and you might be asked to find out no load currents and everything based on these weights and all. But these problems are taught in our notebooks, but they are not important for gate examination. And then another type of problem that you can expect is mixing these transformer problems with circuit problems. That is, you will be given a primary and secondary of transformer, and you will be given turns ratios, and at secondary you will be given some load. So what they will ask is what is the power factor, and what is primary and secondary side impedances, and what is the current that is flowing, and what is the secondary terminal voltage. These are some of the problems that you can expect. So for this, what you need to do is, you should transpose whatever is there in your secondary to primary. That is when you are converting secondary to primary, you should multiply whatever load is there, you should multiply it with turns ratio square. So you should multiply, and then you put it on primary, then you will calculate the current. So now you have gotten primary current, you should divide it by turns ratio to get secondary current. So this is another type of problem that you can expect from single phase transformer. Whatever that I have told you, that is considering no load current as zero, that is ideal transformer. If no load current is specifically mentioned or it is asked in the problem statement, then you have to consider no load current as well. So when you add no load current, and another important thing is, when you are adding no load current and load component current with respect to primary, they should be added vectorially, but not scalar addition should be done. So the addition should be done vector wise. And another important thing in this transformers is drawing phasor diagrams for different types of loads. So you might be given a circuit diagram for a transformer, or a load will be given and the parameters will be given, and you might be asked to pick the right option from the given options. So for this you should know how to draw the phasor diagram of transformer. So this is another type of question. So as I have already told you earlier, one of the most important things is in order to get primary transformer current, you should add secondary current with no load current vectorially. You should not add them in term scalar wise. So this whatever circuit that we are looking at now is approximation of exact equivalent circuit. So what are the approximations that we have taken, that also you should know, because only when you know the exceptions that we have taken into consideration, then only we'll be able to solve the problem correctly. Because if some exceptions are not taken into considerations, then the model will change, and also the solution will change. So that is one more thing. And then other thing that is mentioned in the syllabus is voltage regulation of transformer. So voltage regulation of transformer you can get by you can call it voltage drop, because of whatever transformer impedance that you have that causes some voltage drop. Because of this drop, sending end voltage is will not be equal to receiving end voltage even after dividing it by turns ratio. So you should be able to calculate this ratio, and also the voltage drop. And also there are different conditions for different things, that is different conditions for maximum regulation and minimum regulation. So what these conditions are, you should know, and how to calculate this voltage regulation exactly and approximately. And in the examination you should not be using this approximate formula, you should be using only the exact formula, because in the gate examination recently what's happening is they are testing at about these exceptions, that is where the chances of committing a mistake are more, those things are being tested. So you should be using exact formula, that is involving whole square of I naught square r square cos square phi plus I naught square x square sin square phi by v square power 1 by 2, that you should do. And losses and efficiency are also mentioned in the syllabus. This is again one of the most important things in transformer, that is calculating the losses and calculating the efficiency. So hysteresis loss, as we know, it is proportional to frequency and magnetic field density power 1.6 or something, and into volume of material. And eddy current loss is directly proportional to frequency square, flux density, field density whole square into thickness whole square into volume. This volume thing we are neglecting, because mostly the questions will involve about at losses at one frequency will be given, and you are required to find out losses at other frequency, or total loss at different frequency. For this, you need not bother much about the volumes. Since we are taking those ratios, these volumes will cancel out. So important thing here is the proportionalities, that is what hysteresis loss is proportional to and what this eddy current loss is proportional to, that is thickness, frequency times in hysteresis loss and frequency square in eddy current loss. And b power x, if field density is given as constant, then you can leave it, otherwise then you cannot leave it. This b is proportional to v by f. So if v by f is constant, then you can neglect it. If v by f is not constant, then you cannot neglect it, and you should consider it while calculating. And this is about losses. And losses at some load will be given, and you are required to find out losses at some other load. So core losses will not change, but copper losses will change because they are proportional to current whole square. And then comes to maximum efficiency. So these maximum efficiency problems, what you will do is, first those losses will be given, that is core loss and copper loss will be given. Then you will find out at what percentage of load this maximum efficiency is occurring, and for that load you will be calculating the efficiency. So this is another model which is important for gate examination. So this is about maximum efficiency. So if the problem is getting complicated, then you can use approximate formula for voltage regulation, but that is not advised with respect to gate examination. But if you are stuck at time, or if you don't have much time, then you can use this approximate formula while calculating voltage regulation, that is R times cos theta plus x times sin theta, that will give you percentage regulation. So, and other problem is you will be given in the problem statement that the transformer is having same efficiency at two different loads. From that you have to calculate the maximum efficiency, or the load at which maximum efficiency is occurring. So that is again another type of problem. And also from this type of problems, what they might ask is, you might be asked to find out that percentage impedance or percentage resistance or percentage inductance of the transformer. This you can be asked, and also no load parameters that might be asked for you. And so we have covered about these losses and all. And another important thing from transformers is open circuit test and short circuit test. So it will be given in the problem that open test circuit is whether the open circuit test is done on high voltage side or low voltage side, and even for the short circuit test. So what you need to know is from whatever data that is given from open circuit and short circuit tests, we should be able to find out the voltage at secondary terminals and also the voltage regulation. This is mostly used for finding voltage regulation and circuit parameters. So what parameters you can find from open circuit test are the parameters being, so open circuit test, the output or the test results will be, say open circuit test is test with some 100 or 200 volts applied to LV side will be given, and the current on open circuit or the current drawn from the open circuit test will be given, and also the power loss will be given. As we have done these tests during our engineering, that is, you will have one ammeter and one voltmeter and one wattmeter. So only these three things will be given in the examination. So from open circuit test, you should be able to calculate the cos theta, that is no load power factor. and from this no load power factor you will be getting theta, and from this you are finding sin theta, and from whatever power loss that is given, power loss will occur across resistance only, not across the inductance. So the shunt resistance of no load resistance of transformer you can get from this, that is V naught square by P naught, and magnetizing current that is from I naught sin theta naught. I naught is already given in the problem, and sin theta naught you have already obtained. From this you can find Xm, that is V naught by Im you can do. So now we have obtained both Xm and Rm. So this is one parameter, and other thing is you will be short circuit test parameters will be given to you, that is short circuit with some 10 or 15 volts applied at high voltage side, and this amount of current is flowing, and this amount of power is obtained. The power loss is this much. But for short circuit test, the approximation is no load losses, will consider them almost zero. That is the ideal case. So from this we can simply find out resistance and uh, the inductance. So these are the basic parameters that we have found out. So from these parameters we should be able to find out input primary current and the copper losses, and many things, that is voltage regulation and voltage drop and everything. So this is about open load and no load test. Back to back test is not mentioned in the syllabus, so you can skip this test. So till now we have discussed about these losses and everything in power transformer. Now we'll look at distribution transformer. So the distribution transformer, unlike power transformer, it will have all day efficiency. So whatever losses that we have, it should be multiplied with the number of hours. The constant loss constant loss will be multiplied by 24, but whatever copper loss you have, that copper loss will depend on the load. So if the load is full, then you will multiply it with 1 square times whatever copper loss that is given. If the load is half load, then you will multiply with half square into whatever power copper loss that is given into the number of hours for which the distribution transformer has operated on half the full load. So this is another approach for this is another way of calculating transformer, but this is for only distribution transformer. So we have discussed about equivalent circuit, open circuit test, short circuit test, efficiency, regulation, and now we'll look at auto transformer. So coming to auto transformer, so here the common question that you can expect is initially you will be given a single phase transformer which is which is connected in auto transformer mode to supply some given voltage. So you are asked to find out the kVA rating of the auto transformer. This is one standard question. So sometimes it will act as additive, act in additive manner. Sometimes it acts in subtractive manner. You should be careful while applying this polarity. So this is one type of question that you can expect. And other type of problems are like what is the percentage of copper saving, how it changes, how the voltage regulation changes, and how copper amount of copper changes. These are all just basic formula you have, but you have to know every derivation. Then only you will be able to solve different types of problems from auto transformers. And auto transformers with different taps, those problems are not that important for gate examination. And then you have tertiary winding problems. This tertiary winding we have studied in depth when it comes to theory, but it is more important with respect to problems. That is, you will be having one primary winding and one secondary winding and tertiary winding. This primary winding will be feeding to both secondary and tertiary. So whatever powers that are there, you should be adding powers at secondary and tertiary windings, and you should add them vectorially to get primary power. This is one type of approach for solving these problems. And other being the MMF equation, that is primary MMF should be equal to secondary MMF plus tertiary MMF vectorially. It's not scalar addition, it is vectorial addition. Based on the load, the addition will change. If you have capacitance in a tertiary load, so you have to add it will be leading in nature, and it will be vectorially added in order to get primary winding MMF. From the primary winding MMF, you will get primary current because primary turns will be given. So this is one type of model that you can expect in gate examination. So now coming to three-phase transformers. So three-phase transformers are divided into many groups. But most important connections are delta delta, y delta, delta y, and y y. So you should know how if a transformer diagram is given, you should be able to draw these the vectorial diagrams, and at what angle secondary is lagging and at what angle the primary is leading, that you should know by drawing these vectorial diagrams of three-phase connections. So this you can get only by practice, or otherwise you can refer to Kothari, not general machines book, but you will have it in electrical machines theory. There you have in-depth analysis about three-phase transformers. But if you ask me, it is not that important for gate exam. But if you have solved everything regarding every problem regarding transformers for single phase and auto transformers, then you can concentrate about these three-phase connections and all. So by looking at the diagram that is given to you, you should be able to draw the phasor diagrams of all these three-phase connections. So there are different applications for three-phase connections and all. These applications are not important. And another topic which is important for gate is open delta connection. So you should know how it is different from a three-phase delta connection, and also how the power flow changes, that is the complex power flow, and what percentage of actual load. Actually three different transformers will be carrying three loads. When one of them is open circuited, then the load will change. So how this load is changing and how the power factor is changing, these are the things that you should know. And another connection is three-phase to two-phase connection, that is Scott connection. This is again important for gate examination. And then comes parallel operation of transformers. So with respect to parallel operation of transformers, things that you should consider mainly is what are the conditions conditions that are to be satisfied for satisfactory parallel operation. So these conditions are important for gate examination multiple select questions. There are 4 or 5 conditions, and the conditions will vary for single phase transformers and three phase transformers. So you should know, you should also know these conditions for three phase transformers as well, and how the load sharing changes when the X by R ratio is same and X by R ratio is not same, and when two voltages are same, that is two transformers that are connected in parallel. If they have same voltage, how the load sharing occurs, and if it is not same, how the voltage sharing occurs. So if the no load voltage is same, then you can make it basic circuit, and the load sharing changes, like it will be total load into and is inversely proportional to the impedance, not resistance or inductance, the impedance. So load sharing by one transformer is inversely proportional to its opposite. Load sharing by a transformer is directly proportional to the opposite transformer's load, or its internal impedance, which is same as that of current sharing that we see in basic electric circuits. But here, instead of resistances, we have impedances. And this is one thing. This is about load sharing. And one more thing that you should take into consideration is, one of the two transformers will be it will have less loading. That means it will be loaded before going into parallel operation. So you should stop that transformer at that load, and you should calculate the same for other transformer as well, and you should add these two loads vectorially to get total load that is supplied by these two transformers. Whatever transformer is having less internal impedance, that will have more capacity, and it will share more load. This is another type of problem. And also, if the voltage or voltage ratios of two transformers that are connected in parallel are not same, then there will be some circulating current at no load. So you will be required to find out this circulating current as well. And sometimes you will be asked to find out short circuit current, and IA, IB, and load shared by each transformer, that you can get by first you will be getting the current supplied by the transformer, and you will multiply uh, that current with voltage, line voltage. And this magnetizing current phenomena, this is not important for gate examination. So that is only important with respect to theory, and it's not that important for problem solving. So till now we have discussed about transformers. Now we'll go into DC machines. So the syllabus mentions you have series, shunt, different types of compound generators and motors, their speed controls, and the characteristics of different machines, that is as I mentioned, series, shunt, and compound. So important things that are to be noted with respect to DC machines is speed control. Every year we are looking at least one question from speed control. Sometimes the questions might be asked from voltage control or voltage regulation, but mostly it's about speed control only. And sometimes we are asked questions about starters, and also about armature reaction and everything, but most important thing being speed control. So starting from basics, what we have from DC machines is, we are looking at some magnetic circuits and construction and different types of machines. These are not that important. If you don't know much about basics, then also it is fine. You can start from Emf equation and equivalent circuit of DC machine, and you can start solving problems. So basic equation of EMF you should know, that is 5p Zn by 60A. But you should know about definitions of all parameters that I mentioned. Phi is flux per pole, Z is number of conductors per path, P is number of poles, and N is number of revolutions. A means number of parallel paths, and this is something. And another thing is, if you are required to find out EMF at no load and everything, So first you need to find out flux per pole. So sometimes what happens is you will not be given flux directly. Instead of that, you will be given flux density. You should multiply this flux density with the air gap under one pole shoe. For finding this air gap, you are required to use 2 pi RL by P, because it will be having a cylindrical structure. Cylindrical length should be calculated. Uh, and also in the problem you will be given that what each pole, what is the angle that is subtended by each pole. So if it is given in electrical, you can use those electrical degrees and divide it with 180 degrees. If it is given in mechanical degrees, you should multiply with a number of poles by 2 in order to get you should just convert this mechanical angle to electrical angle, so that you are getting the total flux. And n is number of turns. So if you are given n number of coils and m number of turns, you should multiply them to get number of armature turns. So that is, you are getting number of turns. If you are to get the total number of conductors, each turn will have 2 conductors, that is incoming and outgoing. So you should multiply it with 2. So this is one more area where students are confused. That is while finding each of these parameters, that is flux and number of conductors. I am telling you once again. So in order to find flux, you will be given a flux density in the examination. That is either 1 Tesla or some number will be given. And also you will be given the length of armature and radius of the armature. So you should just take 2 pi RL, that is the cross section area of the armature, and you should divide with a total number of poles, because you are getting, what you are getting here is flux per pole. So now we have gotten a air gap area under one pole shoe, and you have uniform flux density, but you don't know the angle to which this each pole subtends. So in order to get that, you should multiply whatever mechanical degrees that is given, you should multiply it with number of poles by 2, so that you are getting electrical degrees. So now you have a flux per pole, and in the problem you will be given total number of coils and turns. Each coil having some number of turns will be given. You are multiplying these two, you are getting total number of armature turns, and each turn will have 2 conductors, so you have to multiply with 2 in order to get total armature conductors. And speed, whatever RPM is given, that you have to put in 5p Zn by 60A in order to get total EMF at no load. So this is one thing. And there are different types of armature winding, that is lap and wave winding. So these are important only with respect to design part. These are not that important with respect to problem solving in gate examination. But we will have a look at these lap and wave winding at the end of the session. But before that, basic things regarding lap and wave winding is the change in number of paths. For lap connection, number of parallel paths is equal to number of poles. For wave connection, the number of parallel paths is equal to 2. Although the total power that is supplied by both these generators, which are connected in wave or wave or lap, will be same, but there are some minor differences, that is resistance per path will change, and current per path will change, but total amount of power will be same. So now the thing is, the classification of DC machines, this is much important for the examination. That is, there are different types of DC machines, that is separately excited and self-excited. Separately excited, self-excited will be having again shunt connection, series connection. Compound will have long shunt, short shunt, and everything. So you should know the difference between long shunt and short shunt. Basically series and shunt everyone knows, but this long shunt and short shunt, there are chances of committing mistake. So once you know the circuit diagrams of all these machines, then it's just your knowledge of electric circuit that kicks in, and you can use the basic KVL and KCL to find out whatever losses and whatever it is asked in the examination with respect to generators. And one more important thing is knowing the power flow. That is, generator means the armature supplies the power and it is distributed to load and it is distributed to the field as well. So you should be careful with current directions. Sometimes what will be given in the examination is the same machine will be used as generator and motor. You will be asked to find out different currents that are supplied or currents at load and everything. So if you know how the circuit looks like, if the type of generator is given, then you can have a good shot at solving the problem easily. So the most important thing is running the same machine as a generator and motor. So you should be careful with the directions of currents and all. And maximum efficiency problem, this is not that important with respect to DC machines, but the same formula that you have obtained in transformers, you can use the same in DC machines as well. So this is about DC generators and how to approach these generators for different types of questions. And now we look at armature reaction. So what is important with respect to armature reaction is the total turns per pole, ampere turns per pole, which are demagnetizing and which are cross magnetizing. The demagnetizing poles, that you can this will have some formula. If you can remember those formula, then you can solve these problems. And commutation is not that important for gate examination, and this compensating winding, interpoles, and you need not worry about these things, and you need not by heart anything with respect to these topics. Most important things from these topics are that we have already discussed, that is the voltages, the efficiencies, the power losses, and the motor speed control and everything. So you have different operating characteristics for DC generators, that is the no load characteristics, external characteristics, armature characteristics and everything. So you just you can give a look at these characteristics and those graphs, but they are not that important for gate. But what is important for gate is how the number of series field turns, what is the is calculating the number of series field turns for compound machines. This is one type of problem that we are regularly looking at. That is, a shunt generator will be given to you, and so you will be asked to find out number of series turns required to produce the given amount of voltage at a given full load. So in order to find out the number of turns, you should be able to use ampere turns per pole formula. This is one type of problem. And next one is shunt generators. Shunt generators are pretty basic. You need not give much emphasis about these characteristics and all. The most important things will that we have already covered, and they are important only with respect to circuit modeling of DC generators. Only the circuit models are tested for you in the gate examination. Torque speed characteristics of motors are also not important for gate exam. So starting of DC motors, this is again important for gate examination. For DC shunt motor, you have 3-point starter and 4-point starter, but the design of this 3-point starter is important for gate exam. So you will be having a ratio of these currents which is equal to ratio of these resistances. So you will have some factor alpha and everything, but it is better to go analytically instead of going formula wise for this type of problems in gate examination. These problems you can look for in DP Kothari book. And coming to speed control, what students do is they will try to memorize all different types of speed control methods, and they will try to memorize each thing and what are the advantages and disadvantages of each speed control method. But this is not important for gate exam. In a gate exam, what is important is the solution of a given problem. So it is your approach that has to be in control, and that has to be proper. It's not a memorization of different types of speed controls of machines that is important. So you should have a basic look at how different problems are being tackled, or different type of problems should be exposed to different types of speed control problems. Thereby you will have an idea of solving the problem when it is given in the examination. So this is about DC machines. There is not much to discuss about this DC machines. Is least important of all types of machines. Most important one for machines is induction machines, then comes transformers, and then comes synchronous machines, then you have DC machines. In DC machines, the most important thing is speed control, which you can solve by using circuit model analysis. And the characteristics of different machines, this is also not that important for gate exam. And you have starters for DC motors, then which is again important for gate exam. How the value of alpha is calculated and everything, and speed control of DC machines. So this is about DC machines. So in this lecture we have covered about transformers and DC machines. In the next lecture we will discuss about synchronous machines and induction machines. Thank you.